In this video, we're going to introduce exponential functions and show exponential growth and exponential decrease called exponential decay. So this question asks us to look at two functions. One of them start with 20 and then multiply by 2 and then keep multiplying by 2 x times. The other function asks us to start with 160 and then multiply by 1/2 and keep multiplying by 1/2 x times. So we're going to explore that a little bit more, exponential growth and exponential decrease. All right, so exponential functions can be thought of as taking this form. Remember, for f of x, we're just talking about the y value. And that equals, again, a, your initial value or your starting amount, which gets multiplied one time. So see that a has no exponent on it. So we could think of that as having an exponent of 1. And then that value is multiplied by b, called the base. And then we'll keep multiplying by that number again and again, depending on what x is. We'll do that x times. Okay, cool. Now, first I'm going to look at this function where we start with 160 and then multiply it times 1/2 raised to the x power. So right there for x, for our first value, x is 0. So we're substituting 0 as an exponent. Now remember, anything to the 1/2, anything to the 0 power, excuse me, is 1. So this number right here is just the number 1. So we'd have 160 times 1, which equals 160. So our first y value would be 160. Then for the next one, 160 multiplied by 1/2 again. Now x is 1. So raise that to the 1. So 1/2 to the 1 power is just itself, 1/2. And then multiply by 160 and we get 80. So if we sketch this here, if this is 160, then at x equal 1, we're down to 80. X equal 2. 160 multiplied by 1/2 raised to the 2 power because x is 2. So that goes in the exponent. That means we're doing 1/2 times 1/2 because it's 1/2 to the second power, which equals 1/4 or 0.25. And then that amount needs to be multiplied by 160. So 160 times 1/4 is 40. So now for x equal 2, y is now 40, halfway up to 80. So that's here. Okay, let's go one more. 160 now times 1/2 raised to the third power because now x is 3. 1/2 to the third power equals 1/8. And 1/8 times 160 equals 20. So that's x equal 3. And y now equal 20. So that's what we see. And so now you have to think, would you call that growth? Or would you call that decay, meaning a decrease? And we would hope that you see that when we have a base here of 1/2, we got a decrease. All right, so last round we looked at decay. So now let's look at this other function here, where we start with 20. Right? Remember, if there's no exponent, that means it has an exponent of 1. And then multiply that 20 by 2 raised to the x power. So when x is 0, that means our exponent is 0. We said 2 to the 0 is 1. Anything to the 0 power is 1. So then 20 times 1 equals 20. So for x equals 0, y equal 20. Then for x equal 1, now we have 20 multiplied by 2 to the 1 power. 2 to the 1 power is 2. So we're multiplying 20 times 2 to get 40. So now x equal 1 and y equal 40, twice as high as before. For x equal 2, 20 multiplied by 2 raised to the second power. 2 to the second power is 2 times 2, so that's 4. So we have 20 times 4, which is 80. So that's x equal 2 and y equal 80. Finally, x equal 3. 3 as the exponent. So we have 20 multiplied by 2 to the third power. 2 to the third power is 8. 8 times 20 is 160. So now x equal 3. And y equal 160 is really pretty much off the page based on the way I drew this. This would be about 140, but it would be even higher, kind of like here. So if we were to try to continue the curve, it looks something like this. Oh, something like this. And I think at this point, you figured out that this is exponential growth. So see that when our base was 2, we got exponential growth. The last thing I want to talk about is different kinds of bases and what will happen to these bases as we multiply them. So let's just imagine that the base was 1, and we're just multiplying 1 times itself over and over again. One times 1, you know, is going to be 1 times 1 again is going to be 1. No matter how many times we do it, it's going to equal 1. So now let's consider a number just a little bit less than 1, like 0.9. What's 0.9 times 0.9? The number decreases, 0.81. Times 0.9 again. The number decreases again, 0.29. So you see that when we started with 0.9, which is a base that is less than 1, we got a decrease. On the other hand, let's imagine we had 1.1 as our base, and we multiply that by itself, 1.21, times itself again. Sorry, there it is, 1.331. So we see that when we multiply a number that is greater than 1, like 1.1 by itself, we get growth. So that's the last point to understand in the introduction to exponential functions, is that if we get b greater than 1, like a number like 1.1 or 1.05 or even 1.01, anything bigger than 1 or 2, we will get growth. On the other hand, if we have 0.9 as our base, our value of b, any number less than 1 or 1/2, that'd be like 0.5 as our base, because it's less than 1, when we multiply it again and again, the value decreases and we get decay.